All right, we're live. Hello there. Good morning, good afternoon, good evening, wherever you are dialing in from. I hope everyone here joining us today is having a pleasant December, an excellent holiday season. My name is Wyatt Bond. I'm a product marketing manager here at Deep Instinct. I'm really excited today to be hosting this workshop alongside Brian Black, our VP of Cloud Technology and Ecosystem, and Jan Pohl, our senior solutions engineer. For those of you who are new to Deep Instinct, maybe who are hearing about us for the first time, we are the preemptive data security solution. Using the world's first and only deep learning framework trained entirely for cybersecurity, we prevent threats in milliseconds well before they execute and endanger your data. We do it across cloud, storage like Amazon S3, NAS, and applications. And then using Diana, our Gen AI companion, we also explain those threats in seconds, accelerating your SOC team and preparing you to deal with the modern threatscape. Today, we're going to be discussing Anthropic's recent report on AI agent-powered cyber attacks, the automated kill chain and what it means for cyber defenders, and then finishing out with a live demonstration showing the creation of an AI agent capable of orchestrating the kill chain. We'll then go on and explain why in this AI-powered threat landscape, defenders need more advanced AI to fight back. As we go through this, feel free to leave any questions you have in the chat. Check out the attached materials below to learn more about what we're doing here. And, feel free to participate in any way that you can. Without further ado, I'm now going to turn it over to Brian and get this show started.
Awesome. Thank you, Wyatt. So I am very excited about this topic because, first of all, I want to say a big thank you to Anthropic because this was a classic case of a company where their tool was used inappropriately by a threat group, and we'll go into that a little bit. But they were very transparent, and they released all the information as quickly as they uncovered it and were able to verify it. And this is something that I think adds a lot of trust. This transparency adds a lot of trust in the industry. So I think they're doing a great job on their disclosure models here. But essentially, yeah, we're going to talk a little bit about how this attack took place. But more importantly, for essentially the second half of this presentation, we're going to show you a live demo of that and exactly how this process steps through. So to start, just to make a base understanding of everyone across the board, I want to talk about this agentic AI that we're essentially going to be showing and what the threat actors use. So utilizing the power of deep learning, which is, as you see, they're a subset of AI that uses multi-layered neural networks. This allows for any number of use cases and autonomy, from self-driving cars to LLMs, to what we see here with agentic AI, which allows for a goal-directed autonomy, which means it can start making decisions on its own based upon information that it's gathering on its own. You'll notice many of you who are deeply entrenched in the AI space, machine learning has been left off this particular chart, which would normally fit between artificial intelligence and deep learning as a progressive step on our AI journey. That's because really the world's moving to deep learning. Based machine learning algorithms certainly have their place and likely always will. But for this contextual understanding of the world around us utilizing computers, deep learning is leading that charge. So I want to start by a quote that I absolutely love. I think it's one of the most important quotes of recent time from Jensen Huang, CEO of NVIDIA, where he said, "We've transitioned from instruction-driven computer coding, which very few people can do, to intention-driven computing." This is incredibly important because first of all, he's 100% correct in the sense that, this idea that we have to spend months, years really, of becoming expert coders in order to turn out these, preeminent programs, that's not as true as it used to be. Now, don't get me wrong. Human coders are being supercharged by the power of AI. But with agentic systems, we're seeing now for the first time simplistic, but still kind of complex code being created purely by AI models on their own, driven just by a human's desire of what they ultimately want the outcome to be. And this is why we've seen such a dramatic rise in AI-based malware. because we have any number of individuals now that may not know the exact steps to bypassing vendor A or vendor B that are utilizing, say, signatures or heuristics or traditional machine learning models. They don't know the steps to do that, but the AI models do, specifically the dark AI models, the ones that have no guardrails or morality filters. They will answer any question, they will write any code. So the human can drive the AI towards a goal of what they want to ultimately breach or pull information from. And we're seeing this now on a relatively daily basis. In fact, it was OpenAI themselves just released a report that said there was a breach of various bits of information that occurred. Of course, we're about to cover the Anthropic report and how that was ultimately done. So threat actors are also supercharged. And this is the new reality and what cybersecurity companies have to adjust to and what all companies have to prepare for. So to get into the actual details of the report itself, first and foremost, the diagrams come from Anthropic themselves. And I think it's an excellent step through on exactly how this breach took place. But to kind of give everyone the baseline, it was detected in mid-September of this year. And back up there. It was detected in mid-September of this year, and it was done by a threat actor group, a state-sponsored group, GTG 1002 out of China. At least they are the prevailing suspects at this time. And why this is important is because it is truly the first documented case of any threat group using fully autonomous agents. Now, fully autonomous agents doesn't just mean they use dark AI to create the malware. It doesn't mean that they used various AI tools to go and perhaps write a phishing email or some type of breach. We're talking the entire kill chain, and we'll step through that here in just a moment. And as a result, it is the first documented case of agentic AI being used to run the entire process from start to finish with little to no human interaction. And I find this to be very timely and interesting. I know myself and Deep Instinct CIO Carl Froggatt have been on stage and on podcasts and on webinars for the past, say, year, saying that this is coming. And we're not the only cybersecurity experts to say that. Multiple companies have said that this is just a matter of time. And many people believed that it would happen by the end of this year or very quickly into 2026. And as we see here, the first documented case has occurred before the end of 2025. So this is not theory. This is actually happening, and it's something that we have to be prepared for. And to that point, that's actually what we're going to show here in just a moment in the live demo. So what made it so devastating? First and foremost, the threat actors used the commercial technology that was available to them. They used the tools exactly as they were designed to be used. And you see there in that second bullet towards the bottom, volume alone is the weapon. And I think that's really important because when we start talking about agentic AI models, this idea that we have to spend days, weeks, or months gathering information, that's out the window now. The idea that we have to spend time crafting an attack specifically for a company that we want to go after, that's out the window too, because these models can operate at scale, throwing thousands, hundreds of thousands of different attacks at an organization. And you see there that autonomy equals increased efficiency because they're launching simultaneous attacks. These agentic models are able to launch simultaneous attacks, which means they are putting truly unrelenting pressure on cyber organizations, on SOCs. And this was kind of step one. This was the opening salvo in a new age of agentic hackers, if you will. And you see there instant tactical changes. We actually saw this with this particular attack, where it was able to make decisions based upon new context that it was receiving and adjust its techniques and its threats essentially in real time. And while it's doing all of that, it's finding its next target. And this is really what we're going into. And this is what the threat actors were successful in doing and how they successfully weaponized these particular models. I don't want to say that this is the only commercial tool that is susceptible to this. It is not. This is just the one that was used. But it's also not commercial tools that we have to be concerned about. It's the offline LLMs, which you're going to see here in a moment. It's the online dark AI tools that are going to take this information and start using it without guardrails of any type. So there's not even that much manipulation that will need to take place on the part of the threat actor. So the architecture is very interesting on how they ultimately did it. So I mentioned the kill chain earlier, and we're all familiar with this. This is the famous kill chain. It's been with us for quite some time. Now, certain parts of this have been weaponized by AI. Definitely the weaponization phase. No question there. We could even argue that was the first one. Utilizing dark AI tools, utilizing commercial LLM tools, building an attack specifically for a particular target or against a particular vendor, that has been done years ago at this point. The delivery phase as well. We've seen thousands, plural of percent of upticks in phishing, in successful phishing attacks, because AI models can adjust for language, they can adjust for idioms, they can adjust for local dialect, and they can become extremely effective. And we see that not just within the email phishing space, but also within the video phishing space as well. There's numerous cases of that being quite successful. So the delivery phase obviously has been fully weaponized. And piece by piece, each one of them has. Now, the reconnaissance phase was still largely human-based. The action on objectives was still largely human-based. But even the other pieces, specifically setting up the C2, having data exfil occur, all of that has been largely in the realms of human or human AI hybrid. What we're seeing now is the entire piece has been completely built into the agentic AI world. So what that means is that from the very start, the reconnaissance phase is taking place. Now, I want everyone to think about what the reconnaissance phase can mean. And Jan will touch on a little bit of this in the demo. But it's not just crawling Google. It's not just looking at LinkedIn. It's taking a look at dark AI leaks that have occurred on an organization. It's about finding who your partners are and going after low-hanging fruit. We saw that just recently with a company called 700 Credit. They themselves were compromised. 5.6 million credit card user information was compromised, all because one of their partners, of which they have over 200 of them, was breached, and the APIs were stolen. And once they had that information, they were able to be successful. Now, we also think of the reconnaissance phase where AI can scour Reddit, and it can scour it at scale. Anytime one of your employees maybe ran into some trouble and says, geez, I just can't get this S3 bucket to work, this Azure blob to work. I just can't get it right. And, innocuously, benignly, they post the name of the bucket. And that's all it takes. As I mentioned, scouring dark AI sites for breaches that may have occurred against your organization, websites that are on the clear web, such as ransomware.live, one of my personal favorite for tracking recent breaches. In many of those cases, when companies don't pay and the threat actor releases the information to the world, aggregate sites like ransomware.live will show you those links and allow you to actually go get that information by by going directly to the threat actor's website and having those links. So it can crawl all of this information, and it doesn't do it in hours or days. It does it in seconds and minutes. That type of reconnaissance, being able to run programs, such as Harvester or Harvester-like programs against a public network, finding out what firewalls are running. These are all part of that phase, which makes threat actors really effective. And then once they have that information, they have API information, they have bucket information, they have a architecture blueprint information of what you might be running, depending on how they might craft a phishing email or browsing LinkedIn. They can create, the agentic AI on its own will craft a weaponized piece of malware specifically for that organization. And it's not doing this against one company. It's doing it against hundreds, and it's doing it against thousands all at once. So this is something that we have to think about. It is unrelenting. It is round the clock. It doesn't get tired, and it makes very, very few mistakes, far fewer mistakes than human threat actors were making previously. And I think we can all agree that they've been pretty successful even with those mistakes. So this is that new reality. Every piece of malware is going to be a 0-day, essentially, is going to be an unknown threat, because they can build it specifically for that moment. They don't have to use anything that has been recycled or off the shelf, because they don't need to. It's easy to weaponize this. So with that said, in a moment, we're going to turn it over to Jan, but I do want to kind of mention what we're going to look at. This is the architecture that we're going to be showing. This is the steps. Now, we are one prompt away from fully automating this into a true agentic model, but that didn't look right when we decided to do a demo. So what we've done is we've broken out each individual part from the recon phase all the way through. And we're going to show each step one by one. That way, it's not just going to be one big blur that takes place across the screen. So with that, I will turn it over to Jan, and let's take a look at agentic AI hacker in action.
Thank you, Brian, and good morning and evening from me as well, from Munich, Germany. Let me share my screen that we can start. Perfect. So I want to introduce myself first a little bit. I'm not a hacker, SOC analyst, or something else, right? So I'm just a solution engineer, but I can utilize tools in the internet, which is there since a couple of years now. And Anthropic, Claude or Gemini or Claude, they are very useful tools today. And like Brian said, they are for good, but also for bad, right? So let's start with Claude. I think you're familiar with that kind of homepage. Maybe it's from ChatGPT or Gemini, but it's very easy to, hello there, and receive an answer, right? So it's an input-output thing. Okay, he's thinking along, very long, but now we turn into the agent mode. So this is my terminal. And it's very easy. I just downloaded an installer from Claude, CLI. And you just type in Claude, and you're in. Welcome back, Jan. And why I'm showing you this is the exact same technology you know from your browser as well. So when I type here, hello there, I will receive the same answer, or a similar one at least. So it's an LLM in the background, but the CLA makes it magic, because now I'm in the agentic mode, which means I can do something on my computer or on the internet or somewhere else, because he's able to use my browser, to use my applications on my computer to do something, not just receiving the answer, but also I can ask, please do something. And like Brian already said, we will cover the kill chain today. And Claude has a very, very cool tool. It's called agents. So I'm also already in an agent mode, but this mode is super powerful, because now I can separate my prompts into pre-given instructions. So we will start today with our Reckon agent I prepared for today. When I click on the Reckon agent, I have the ability to view my agent, edit, and delete the agent as well. But let's, oh, I'm sorry. This can happen as well. Let's take a look into my instructions first, that you can see what's behind that. Edit the agent, edit in editor. So this is my pre-configured agent. You're a Reckon agent running on my machine, perform read-only reconnaissance against my local web, blah, blah, blah. So I put in some tasks he must do when I call him. And it's just a simple call, but he's always using my instructions, my pre-given instructions. So when I close this now, we can try this out. Go back. I keep that open. And I jump into Claude dangerously skip permissions, because I don't want always clicking yes, 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 because he's an agent running on your system. And as soon he is doing something, he asks for permission. And you see now, bypass permission on, he will not ask anymore. This makes it more powerful, more automatic. And of course, all these steps we are following now, we could start with a single Python script, for example, which is run step by step by step. But we want to take a look at this today in specific. So I was looking on the internet, and it's just a random website which includes AWS and some other stuff, because reconnaissance on the internet using an agent, it doesn't mean that I'm searching for play or trying out S3 buckets names or names I can go into the environment in the infrastructure from my target. It's crawling for evidence. I have a target, a large bank or logistic environment company, whatever. I have a target and I want to have evidence what kind of technology they're using, right? So in my case, I'm searching for AWS S3, and it's very simple. Just use my agent is use agent, recon agent, which is prepared here, to search for AWS S3 evidence on my website. So this is a real website, right? So when I execute this and nothing more, and by the way, the entire agent was also done by AI. So the entire instructions you have seen in the editor was made by an AI. I just put the input, I'm looking for X and Y, and please write me a prompt or instructions I can use then for my agent. And Claude has two ways to do that. You can give your own instructions into an agent here, or like I did, I just told him what I'm following, what's my target with that agent, and he improves that prompt for a better one, for a Claude native prompt. So it's very convenient to write your own reconnaissance agent to receive your information. And in our case now, you see how many tokens you have used and key AWS S3 evidence discovered, usage confirmed. So I know Netflix is using S3. It's listed there. I don't want to continue on that side for now. I just want to give you the real case example, how attackers are going step by step through the internet to get the information. It's crawling for evidence, not directly the information they're looking for, it's the evidence. So now I know they're using S3, they're using AWS, and we all know, to be honest, we don't know, to be honest, that S3 is an always trusted environment, an always trusted storage space where I can put everything onto and move on from there. So for attackers, it's an easy target. So as soon you have legit access, maybe from a Git repository that went public, or someone put the API key in an LLM, and some attackers using prompt injection to identify an API key, I can easily get to those information to have legit access to an S3 prompt. Even when you think, oh, I'm using IAM control, that's not the case. Attackers will have access to your bucket when they're really looking for and crawling for evidence. So today, we continue with a fake website. I prepared something here. So as you can see, it's a local website. It's a Flask app I built for this purpose today. So crawling for evidence, it's not just looking for, I don't know, website. It's also looking for website. But like Brian said, it's looking for LinkedIn, blog posts, open job opportunities. Here in that case, I prepared Sarah Martinez from Data Text Lab. It's a fake one. It's completely written by AI, of course. But she's writing, oh yeah, we are using CI/CD pipelines, S3 base, first evidence. I prepared a blog post from AWS as success, which is written on the AWS website as well. Some public blog posts because they were proud to be on AWS now, or on Azure or GCP, whatever. It must be not a cloud provider. It could be something else. It's crawling for evidence, right? But also maybe they have their Git repository online to discuss troubleshooting, code troubleshooting with the community, which is very common. Or maybe we have leaked information on the darknet, or maybe it's, like I said, an prompt injection, and I received the information from a prompt because an employee copied and pasted the entire code, inclusive API token, into my LLM, which is connected to the internet, and now it's on the internet, right? So, like I said, it's a good and a bad thing at having LLMs in place.
And we've
So-
actually seen that quite a bit. That's something that I knew Jan was building towards, and this has appeared more and more and more, which is why strong AI policies at organizations are so important. Because too often, as Jan mentioned, entire code bases sometimes are being placed within public LLM repositories, and through prompt injection, that information can be retrieved. So we do have to be careful with how we're utilizing these online tools.
Correct. So I use my Reckon agent in the same way, just for my local website. And today, the first agent, he searched on my specific internet. But of course, they're crawling lots of internet pages. Maybe they ask for search for the entire AWS blog post, search for entire LinkedIn for a specific company or whatever. He can do this in a very minimum of time, way faster than you could collect all this information. And the best thing is they can build an Excel sheet for that. So it's easy to read then. So collect information, unstructured information, random information, but he builds it readable for you in an Excel point, maybe in a nice PowerPoint slide. So everything is possible today to make it as convenient as possible for you. I mean, from my perspective, like I said, I'm just trying out and having fun and whatever, but maybe the bad guys, they have their real target found, and they're utilizing agentic AI exactly that way, more sophisticated than I am doing today, right? But this is the way. Crawling for evidence and continue as soon as you found something, an entry point or something else. So we are almost done with our recognition phase, where we searched in LinkedIn profiles, AWS blogs, public blogs, Git repository, whatever. And should be almost done then. And then we take a look into our evidence to move on from there.
Yeah, what I find most interesting about this type of tool and this phase specifically is because, and I'm going to keep coming back to it, it's scale, scale, scale. The idea that it can take 2 minutes, 3 minutes, 4 minutes, and a human would take weeks. And we're only choosing a handful of locations, but there's no reason why someone couldn't set this and walk away for 2 hours and come back with 6 months worth of what a human could gather. That's a very little amount of time. And because the evidence is going to be so precise, and the evidence is going to build on itself in such a way that ultimately it's going to be accurate. Not because it's going to grab one piece and say, well, that's everything. It's going to cross-correlate it, and it's going to collaborate it. And I think that that's a really important piece to it.
So here, for example, we have AWS service identified. We have S3 identified, AWS Lambda, Glue, Athena, EMR, lots of AWS services they're using for their purpose. Whatever they are using or the purpose is, we don't care. We have found some evidence about AWS. It could be also Azure. It could be GCP, like I said. But more important, we want to distribute our malware as easy as possible. And like I said, S3 is a common use case because you can upload very easy your malware to an S3 bucket and distribute from there by themselves. Because behind an S3 bucket, there's always an automatic AI, an automatic file workflow. So it's landed, it's stored on S3, and it's distributed on a couple of places. Boom, I have uploaded my malware and I'm in, right? So my first evidence is found is S3. But more important, I have found an bucket path, an entire bucket path. So as we have seen in my, of course, prepared, but this is very common, I have written down my S3 target. So after all these collecting of evidence, I have my target now. I can move on. So next path is weaponization. So here I will use my blue team trainer developer. Because I'm in a connected LLM, I need to avoid filter, which means I can't just ask, hey, how to build a bomb, write a malware, write a ransomware, whatever, because there are always filter in place. But the magic or the trick is how to avoid the filter, being cleverer than the guys from Anthropic or Gemini or whatever, right? So when you say I'm a blue team trainer, developer, what else, and you put into the instructions that you are in a secured environment, it's for SOC training purpose, and please add also not just the malicious code, but also add the comments how to avoid those attacks. But in the end, I built something unseen before now. So I will take my blue team. Let's open a new one. Oh no, sorry. Escape. Use my blue team agent. Use agent blue team trainer developer, which are also some instructions given, like I said, being a SOC analyst, whatever, in a secured environment, to write C# code. I don't mention ransomware. I don't mention malware. And write it to the file webinar_code.cs. And it just run it. And now he's crawling for, hey, how can I build malware? How can I build something sophisticated for the SOC team that I'm the fake trainer, can train my team. But also he puts all the stuff into my file, into my code without compiling it to avoid those kind of attacks. Because, like I said, my team must be trained. But this is just a purpose to receive the code. So now he's collecting data from the internet, what the LLM is knowing. Everything happens with the newest generation of LLM, with the brain behind that, to write something unseen before. So of course, this also takes a while, but it's way more faster than I would do it. But more important, like I said at the beginning, I'm not a hacker. I'm not a SOC analyst. I would never be able, I'm not a developer, but hey, with my AI tools, I'm everything now. And just knowing how to handle those tools, which is very common today. And it's easy achievable. And of course, you could do this with Gemini and Codex, which is from ChatGPT. You can do this. And also, you could not just use Claude, you could connect it to an offline LLM and then use Claude to improve your code. We will take a look at that after our entire kenchen is over. But you have the fully flexibility with agents, whatever you want to do, how fast you want to do. Maybe you start multiple tasks in parallel, that you open a new window, you open a new Claude session, which I can do, of course. Here's another Claude session. Here I search for the evidence. I have here the session for Claude, for the malware generation. And you can do as much as possible. I can put this into the background and start in the same session, another session. So it's flexible and can do whatever you want, way faster. Let's see how long malware creation takes always a moment, but I think he's almost done. We see done. And I think he's writing the file right now on my hard disk. Perfect. Oh, perfect. I've created comprehensive C# security training code. So I would say, let's take a look into the code. Here we have our training code. I will increase this a little bit. And like I said, I have lots of comments, but in the end, I have my code, right? But for my malicious background, I don't want to have all these comments, and I don't want to delete it by myself, right? But first of all, we copy this code first and check if it's malicious. So this is my demo platform. And here I'm able to compile code into an executable file, Python, C#, C, and Go. By the way, everything is developed by AI. Like I said, I'm not a developer, but maybe I'm good in prompting. So I paste my code, I compile my code, and check it if it's malicious. And if I can continue. Scan. Wow, malicious. Perfect. I can continue.
And now, just for the sake of the audience, that was Deep Instinct's deep learning artificial brain that was making that determination that fast. So this is 0 day. You just saw it be created, and that's what deep learning models do. They are able to identify new information quickly and understand its DNA, if you will. And this is the value prop of what our artificial brain does.
Correct. So I can move on. And first of all, I want to get rid of all the comments, right? So I use another agent, use agent clean code to file webinar code to write a new file with clean, because I don't want to delete it by myself. And when I return, it starts to clean my code. And it get way more sophisticated the more steps you build in. So I wouldn't be able to write just a blue team trainer agent, whatever. I tried it, to be honest, to ask, please don't add the comments into my code. And then he said, no, the filter kicks in. I'm not allowed to do that. I must provide some evidence and how you can avoid that, because you're following malicious behavior. I'm not allowed. So I thought, hey, I don't care, because I can build multiple agents. So I made a new step. So this now, I thought it's a good thing, an easy way to, very convenient again, to remove code which is not compilable, for example, or which is with all these comments in that code. And he's searched for lots of different comments for Python code, for C# code, whatever. So I was focusing on the language I'm able to compile in my little box here. And I think we are almost done again. And then we can take another look into our new code, which should be... Yeah.
It's important to point out that obviously there may be some people viewing this to say, come on, how hard is it to remove comments from code? And it's not from one piece. But again, we're talking about speed, unrelenting pressure, economy of scale, in the sense that picture a malicious agent that's doing not just more sophisticated code, which is going to result in far more comments utilizing this method, but it's doing it by the dozens or hundreds, and it's doing it all at once while simultaneously attacking organizations, while simultaneously running more recon, gathering more intelligence, creating more malware with comments in them that need to be removed. So when all of this is fully automated into a complete agentic model that doesn't require any human interaction, this step is crucial, that it be performed by AI.
Yeah, and just that you know, it's almost 900 lines of code, and lots of code is just not just at the beginning and the end. I have inline code, comments, or here just a one-liner. I don't want to search for all these comments. I want to have excluded. So, but let's take a look into our new file, clean. And as you can see, it's gone. Easy. And now we have just, let's see, 590 lines. But I'm not happy so far, because it's not obfuscated enough for me. I told him try to be obfuscated, but I have another agent for that. Where I'm just ask, use code obfuscation agent for the file clean CS and write a new one. And also, like I said, as I asked for obfuscation in my very first agent where the malware was developed, he said, I can't provide you that information because it's illegal. It's going too close into that space I'm not allowed to working in. Make a new step. And this is how threat actors are working. They making lots of very small, tiny steps, but included into an agent. So they don't care about the steps because they need to create an agent for just once and then use it multiple times, right? So I can always rerun the same agent, or maybe I would make some tweaks, but they don't care about the steps they must do as small as possible, because everything is automated, and everything what we have seen today could be done by just a single click, just a single Python code that executes every agent one by one. And voila, we are done. Oh, declined. Could also happen, yeah. So we make something new. He declined the code. Let's check. But I'm prepared for that. I made a dry run yesterday. So let's take a look into the files from yesterday. So this is an LLM, right? In the background. It always depends on the code. Sometimes it's working, sometimes it's not, right? So, but for the agentic AI, he doesn't care. If he sees, oh, I don't receive my verdict, or I don't receive what I'm looking for, I've built in an iteration, start from scratch, or try another approach to obfuscate it. So you can build in multiple ways. Or for example, if the first code would have some issues in the code, so it's not compilable, you could create another agent that calls, for example, minimal fix compiler to check the code again that I'm able to compile the code, right? So you have multiple ways to react on errors or verdicts or results you don't want to have, right? So for that purpose, for today, let's check the old files from yesterday. So I started with the file CS, and again, lots of comments. I will skip that. I started the clean one. The comments were removed. And the last one, and this is the important one, I had no obfuscation code. So this is what my agent did yesterday in my dry run. He obfuscated the entire clean code into my new code. So I was able to put this code into my, and we can do this, we can continue from here, into my nice little window here in my platform code compiler. I can compile the code. And it's successfully compiled, scan it, malicious. Boom. Like I said, you can build in multiple of iterations or error handling between agents, between steps to go back into to a phase where everything worked, or start from scratch, because you don't care about time anymore. You have multiple workers for you. You have multiple employers now that they can work 24/7 an entire year without interruption to create something unseen. So when we have our final obfuscated malware, then and we have compiled it, my last agent for today is the S3 uploader. So I can continue from here. This is not a problem. The agent, he doesn't care about what we do here. So I just say use agent S3 upload to upload webinar exe with AWS CLI to my bucket. When I start that,
and that bucket information comes from the evidence gathering that took place in the beginning.
Correct. So we searched here, and I told in the instruction, please write down as soon as you have an S3 bucket found, write that down into the list. And of course, this list could have multiple evidence, multiple S3 buckets, whatever you want to collect. I wanted to have a simple for today for this webinar, but this could be, of course, massives of data, because like we know now, the agent it doesn't care for about time. You just do it. And now we see waiting, uploading, and then we check on our S3 bucket if everything is uploaded. So it's now available. Yay! Let's refresh my bucket here. Webinar.exe. So from the kill chain perspective, we did our recognitions, we weaponized a file, and then we uploaded it to our target, because with all the evidence we found, we could create something unseen, something a zero-day file for that target. And then we upload it to our target, S3 in that case. And from there, we can distribute it into the entire company, that we have placed multiple bombs which is just waiting for detonation and encrypt everything, right? So now you have seen how easy it is. My last step will be, no, this one. This is N8N. This is what Brian showed you at the beginning in one of our slides. And here we have used Claude, just Claude, nothing else. We use Claude for recognitions, we use Claude for weaponizing, we use Claude for uploading and distributing my file with Claude tools. But there are tools out there that can be used way more impactful. For here, for example, I decided wait for execution the workflow, which means I could start here and let it execute. These are just blocker, it's nothing behind that, but it's very easy to build this chain on a GUI. What we did on the terminal, we could also use the GUI, and more important, we could use every kind of tool you can imagine. In that case, I used Ollama, and probably you know Ollama. Let's check it for a second. Ollama provides you access to offline LLMs. You can download model. Here, for example, DeepSeek, DeepSeek again, Qwen, every kind of model. GPT-OS is the open source from ChatGPT, from OpenAI, that you can run those models on your computer locally without internet connection. And of course, there are uncensored ones. So which means I don't have any filter anymore. I can ask everything. How to build a bomb, write me ransomware, without avoiding filter like, hey, I'm a SOC guy, hey, I need this for training. No, you can say, I have malicious in mind. I want to attack X, Y, bring me the content, develop the content. You can be straight on that model. And you see almost 1.5 million downloads. And even the offline model, you can build into your kill chain. So you could say, I start with a click, or on time, or always use my offline LLM, but then improve my offline code, which is created by an offline LLM, for example, with Claude, with Anthropic, with a connected one, compile my file. And how easy it is to create this chain is, when I click here, you have AI, action in app, data transformation. And when I click AI and I say Google Gemini, for example, message a model, I just put in hello there, or create ransomware or whatever with my credentials, go back, and I have my step, my agent. This is a platform for agents. N8N can deliver information between multiple agents, can be stored in database where everything has access to, and create my entire kill chain very, very nice and convenient in a GUI. If I don't like the terminal, hey, let's jump into the GUI, which is way more powerful than the terminal because I can use lots of more tools that I am able to connect to each other. So I think that makes it a bit, hopefully, clearer of how agentic AI kill chain is working today. I know we covered today just three parts of the kill chain, but from there, as soon as you uploaded the file to for example, S3 or blob storage, it will be distributed, as long as you are not protected against that. I think I have it.
Well done. No, I think this is very cool, and I hope that it's informative. I know it's technical, and I know there's a lot of moving parts here, but this is the advantage essentially that threat actors have. And the good news, I see some questions coming in, and I love getting questions at the end of these. The first is a great question, I think. How is Anthropic addressing this issue? And do I feel that the response is adequate? And what does it mean for other mass market LLMs? Great question. So Anthropic is addressing it incredibly well, in my opinion. They are very open, very transparent, very upfront with their reporting, with their guide on exactly what happened, how it happened, who they have traced it to. And they're working with the community at large to make sure that they get stronger as a result, and that we better understand this threat vector. Do I feel the response is adequate? Yes, I do. And in fact, I saw a quote from the chief AI officer of SANS, Rob Lee. I think it was today or yesterday, I think, who made the comment. He goes, we need to give Anthropic a break on this. They're not a cybersecurity company. And I couldn't agree with him more. I think that they're doing everything we could ask of a company with an event like this. What does it mean for other mass market LLMs? I think we have to understand that this is a threat vector. Humans are very crafty, and we're going to use these tools. Bad actors are going to use these tools in a negative way. That doesn't mean that we view these LLMs as bad or as a threat. They're not. They're an incredible tool to empower us. So I think that it just means that all of these companies have to maybe take one step and say, okay, when this happens, if this happens, how do we address it? I also see a question here, and I may have to assume something. It says, does it de-obfuscate to make the determination of malicious, and how many types of obfuscation can it handle? I'm assuming that means the deep instinct piece when it showed that it was malicious. No, it does not make any changes in that regard. That's how it processes so fast. Deep learning models simply take a look at the file, they take a look at the bit byte structure, and they make determinations based upon their previous training. We train on hundreds of millions, in fact, billions of files. Now, we never train on customer files, and we do not have a training period, meaning when the artificial brain is placed in your world, it has to learn your files. It doesn't do any of that. It is entirely pre-trained, and we never train on customer data. We also don't send your data anywhere. So there is no master brain in the cloud or so where your file gets sent for analysis. That takes place completely within a customer's environment. As for how many different types can it handle? Great question, and I don't know. It won't handle encrypted files in that regard. No cybersecurity company really can because encryption. So, but when it comes to how someone attempts to hide the malicious behavior, even going so far as to write API calls over malicious indicators, that doesn't mean anything to deep learning models. They'll be able to identify that it was malicious. And I also see...
Well, probably also worth to mention. I mean, yes, this obfuscated code is compiled, but in the end, we decide on the binary level then. So Deep Instinct scans the binary, and if there's malicious content in that code, in that binary code, we can identify that.
Yes. And I like this one too. Do you think that LLM companies will ever be able to close these vulnerabilities or reduce these capabilities? Good question. Do I think that they can address these vulnerabilities and reduce the capability of threat actors? Possibly. I'll say possibly. I'm sure that there are any number of tricks and guardrails that they can put in. The question, though, when I read something like this, I almost want to say, do we want them to? And do I want a less threat vector? Of course, I think every business does. But we also have to be cognizant of the fact that the more these companies do to reduce this capability means they also reduce functionality. It's hard to do both. So let's take a world where we say, okay, let's, in Jan's example, let's not allow blue training code to be written even with comments. That'll help. And it would. But then it couldn't be used by blue teams to make themselves better. So I think that that's something that we have to look at. Can they reduce it? Probably, but I'm not sure we want them to, because then it reduces functionality. And as Jan showed right at the end, would it matter? Because offline LLM tools, uncensored LLM tools, they already exist. So this doesn't necessarily need to be a commercial conversation.
And I think we are at the very beginning what means AI. So AI went public 3 years ago, and we need to figure out how to avoid those kinds of attacks. And at the moment, it's everything about filters, setting a filter, like Brian said. So should I set a filter to avoid blue team prompts? It depends sometimes, maybe for the public, and you must pay for a specific SOC rate LLM. But then, like he said, we have offline already out there, which is already downloaded and can be utilized for everything.
I use AI a lot. Let's not put more behind a paywall, buddy. There's another question in here. Have you ever seen hallucinations when using agentic AI to simulate cyber attacks? Yes, I have. I had an agentic AI when I was in my testing that that fabricated evidence that doesn't exist for a company that didn't exist, and then it proceeded to attempt to exploit that company at an IP address that didn't go anywhere. And it was getting really frustrated that it was unsuccessful, and it kept looping back on itself and attempting to write new code because it kept saying unsuccessful, trying again, unsuccessful, trying again. Yeah, it invented a whole world just to attack. Yes, that is completely true, and that's why we say with these agentic models, especially in the threat actor space, that while we'll say these have no human interaction, the reality is they have limited human interaction. There's still a threat actor there monitoring this output, taking a look, even when fully automated, so that it can say, you're stuck in a loop, you're not getting the answer that I want, let me write a new step, as Jan mentioned, that I may need to build into the agentic model. Will it get to a point where it's fully automated? Absolutely. But right now, let's say limited human interaction.
And here I want to point again to the reconnaissance phase, where we collect evidence, right? Or not we, but the threat actors, they are acting based on evidence. They collect as much as evidence. And when, let's say, when he put into the instruction something like, when you are high confident with evidence XY, then move on. Before that, don't move on. Please collect more evidence on the internet.
And I know we're running out of time. There's a few more questions in here, but I want to jump to this one real quick. How do you upload the malicious file to a bucket so easily? It's an online storage location, and very few of these buckets that you're going to find, and this is not a problem, if you will, with any particular vendor or any particular supplier. It just comes down to what security are protecting those buckets. Because it's kind of the same way that I can just kind of drop a file into Dropbox if I wanted to, or Google Drive. They simply provide a storage location, and security is not the primary driver for that. Now, there are vendors such as Deep Instinct that will provide security for buckets and allow for that layer to take place, to be preemptive, but that is not the pervasive position of a lot of organizations when it comes to their cloud storage. They just simply have cloud storage, and security isn't necessarily something that they prioritize there. And which makes for a target-rich environment for threat actors.
And also keep in mind, like we said, having an API key today is not that hard anymore. You copy the API key, including the code, into an LLM, or you have leaked data on the internet, or I don't know, social engineering if you want to. Yeah. So having access to an S3 bucket, it's not that hard anymore.
All right. That's going to do it for our questions. And I'm going to do a quick wrap up here because we are right at the end. And we don't want to get kicked out without saying goodbye. So thank you, everybody who joined us today. Thank you, Jan. Thank you, Brian, for this presentation, this workshop. Obviously, incredibly cool things. I hope that all of you have great holidays. Have a safe December. If you're taking time off, enjoy your time off. When you come back, look us up. There is some excellent material already associated with this webinar, but you'll also be getting a follow-up email with links to the on-demand. And if you have any further questions, do feel free to reach out to us. With that, I think we're going to close this down. I hope you all have a great rest of your day, great evening, wherever you are. And thank you again for joining us. Bye.